7 particles per whatever is not a near
Why can't
perfect
they get a
vacuum. Or
perfect
you know what you're talking
vacuum,
about?
so
It's basically a near perfect vacuum. It's
Wait,
it's
why can't they get a perfect
99.99% of perfect vacuum. What's your
Why
point?
can't they get 100%?
In a perfect vacuum. You know that, right?
You can't get all the particles out of it.
Why
They,
can't
they
you get
spend
100%?
they use
What's
cryo pumps.
the difference
Listen,
between 99.999 versus
high-
99.8?
I think Zanuck was talking.
the highest pressure you can get, the highest pressure you can get on Earth in most scientific experimental mechanical engineering apparatus is 10 to the minus 11. That's very difficult to achieve. It takes a long time to get to that point. But 10 to the minus 7, 10 to the minus 5, 10 to the minus 3, those are very, very high. Those are near ultra high vacuum environments. The density or the vacuum chamber at NASA is probably 10 to the minus 3 or minus 4 in that range, which is still very close to zero.
Okay, so the point is, it's not zero. It's not a perfect vacuum. Correct.
You're joking, right?
Well, what do you think the practical
because there
difference
is no-
between 10 to the
because
minus
there is no
5, 10 to the minus 11, and 10 to the
It would
minus
fall at the exact same
17
rate,
actually
right?
is?
Correct?
In reality, you need some pretty
I don't think he learned
exceptional
exponential.
circumstances to notice the difference between those pressures.
Yeah, but is the medium still there?
Basically not.
When it's 99.99% not
that?
there, what's your point? You're grasping at
Does it-
straws and you know it. Like
Bro,
honestly,
what
is this
was
really your
the
strongest
medium
argument?
then?
You
So
don't.
you
Your
really just
vacuum is
want to
only
you just want to
99.99%
talk
there.
today, huh? So you're just going to take over every conversation because you were just down in that other room trying to take over that conversation. Now you came up here and now
I
you're
give you an
taking over this
example with the
conversation.
NSA and you just left.
No,
so
because you're
I'm
ridiculous, and now you're up here trying to take over this conversation.
not taking over anything. I'm just.
But
this
you
is-
are
this
though.
is some of the
You
most
just
silly
talked
logic
over
I've ever
Zanuck.
heard.
weren't
You
even
got
letting- Then you need to step back then
0.00001.
and let somebody else talk if you
Yeah,
think
go
this
ahead.
is
I'm
nonsense.
responding to the guy who responded to me.
No,
today.
you
I
took
know-
over the conversation,
10
No,
times-
and you wouldn't let Zanuck talk.
It's 10 times larger.
That was
than 10
Brummy
times
that wouldn't let Zanuck talk.
17. 10 times 10 to the negative 7 is
Just a
10
little
times
butthurt
more.
from down there.
Well, having another Brummy doesn't help.
Butt hurt. I don't like what you did because you don't listen. And this is another example
No,
of
you
that.
don't
You
listen.
came
You
up.
literally
No,
left.
you
You don't
don't
listen.
listen. And you came up here and you jumped right in without listening. These
No,
people were having a conversation.
me and him were having a
and
conversation
You
to it.
you jumped
you,
right
you
in.
showed
You literally came
you couldn't
up here
even
and started
define a
talking.
word for half an hour. You couldn't define one word. Okay, so you go
I
figure out
did
your definition.
though.
Oh wow, man.
Oh my God. You're insane, and you just want people to listen to you talk. That's your problem. You jumped in this conversation and you've taken it over.
I
Let
was
the people
responding
who
to
are
the other
talking
guy,
talk.
and you're the one interrupting right now, so let us finish our conversation.
Social media, man.
Oh, it's your conversation now. That's the
Ruining
point.
society.
It's a conversation, but Twit's just complaining about it.
Should not be able to say shit like that.
The point is, we'll never get a perfect vacuum ever, right?
Yeah,
You'll
and the
never have a
point is,
perfect
we
vacuum.
can't say that they're falling at the exact same rate.
95%.
Not about the vacuum.
Right?
About the schedule.
There is some.
Where's the schedule?
So if the
How
vacuum
long of a block can I get penciled in for my conversation?
I was talking.
How long?
Now he's talking over
How
Serge.
long is our conversation? I mean, how long? What's our time limit? What do we get? Where's the schedule? I want to sign up. I want my conversation, damn it. Where's mine? Where do I sign up?
Good luck
And
with
how
that,
much
bro.
time do I get?
Make
How
a
much time have
checklist.
you had, Hippity?
Make the checklist curve. You make the time.
I
list
just
and
got
everyone-
back like 2 minutes ago,
Pick a
and I
nice
heard
font.
this shit.
Pick a
And
nice font.
shocker, it's Hippity involved in another argument about how much Hippity is talking, dominating the fucking room.
He's
I'm
horrible. He doesn't
completely
listen.
aghast by this.
He doesn't listen.
No, to it, you couldn't define a word for half an hour.
I
You told me who
did.
could
I
do it.
defined it over and over
Alright.
again. You don't listen.
You can't shut the fuck up for half a minute.
Because, yeah, that's why he can't listen. He's too busy talking.
You're having a
So
great
how long would they
conversation
have
to it.
to pump?
Thanks for that beautiful interruption.
How long would they have to pump to get a perfect no pressure at all?
How much pressure is 4 times 10 to the negative 6 torque?
But
What is
I'm
that?
just saying, is there still pressure?
25. What is it? 4, not 10 to the negative 6. 4 times 10 to the negative 6.
There's still pressure there. So that means that if we had a vacuum chamber that was high enough, they would
Yeah.
fell at different rates. You would appreciate that they fell at different rates. The only reason they don't,
There's
we
still
can't see that they're
pressure there.
falling at different rates is because the vacuum chamber is too small.
What effect would the pressure that's there that you're whining about? What effect would that have?
Who knows? The point is that they fall at different rates. So there's no 9.8 meters times 10 per second squared constant. We
No
don't
one
even
said
know
that.
actually what it would be in a perfect
No one
vacuum.
said that
We've
the
never
speed that
actually
things fall
ever
on
measured
Earth
it.
is a constant.
One
Yeah,
could argue that
the gravitational
1
hold
times
on.
10 to the negative 7
Hold on.
is
The
10 times
gravitational
more than 1 times 10 to the negative 17. And as such, it's moving 10 times faster than it would in a perfect vacuum.
No, it's not.
No, that's not true at all. That's
You
not
could
how it
argue
works.
it. You've never measured it in a perfect vacuum.
No, that's
so you
not
don't
the
know.
that's not how it works. You just made something up.
That is how it works.
No,
We
it's
know how
not
to
how it
measure
works.
drag forces.
Something that is seeing 10 times the pressure doesn't mean they're going to go 10 times as fast. That's not how drag works.
Well,
Pop it in
why
the
wouldn't
drag
drag?
equation
Why wouldn't drag slow it down?
It
though?
does.
Like, so
It
is
does.
it 9 point? So what is it then? Outside.
It's
of the
really,
vacuum?
really close to 9.8 meters per second squared.
The
Well,
truth
as
is
it
they
starts,
don't know.
Nine
They
as
never
it
measured
starts,
it in a
hold on,
average.
as it starts to move, the acceleration is 9.8 meters per second. That's fixed. Doesn't matter what the air pressure is. No matter how far they travel will determine how much drag is created along that path, and that path will determine, and the size of the object, the shape of the object, its drag coefficient, the frontal area, all in the density of that medium will all determine how much drag it produces along the way at any given velocity.
So medium has something to do with rate of fall.
Absolutely.
But,
But it's much greater effect at higher speeds.
Effect.
At high speeds, that has an effect. That's why we have terminal velocities. But before that, it's almost negligible at low speeds.
Yeah, it's negligible.
Have you ever measured it? Has anyone ever measured it in a perfect vacuum?
There's no such thing as a perfect vacuum.
It's
What?
perfect vacuum literally
There's no such
cannot
thing as a
exist
perfect
in the
vacuum.
universe.
Why
It's
not?
impossible.
Because you can't possibly get every molecule, every atom out of that chamber. That's why
Maybe
there's
not in our world, but why can you fit an entire universe?
no nowhere.
What's your point? It's 99.99% a perfect vacuum.
My
Like,
point
why-
is, whenever they say vacuum, they make it seem like it's 9.8 per meters per second squared in a perfect vacuum.
Nobody
Okay,
says perfect.
and
Every measurement ever taken has been in a non-perfect scenario. You have results that converge upon a point, and the result of gravity in decreasing atmosphere, it converges on 9.81 meters per second.
Here's
How
a
about
question.
this?
When does it become a
Before you
non-perfect
go,
vacuum? A near
hold on,
perfect vacuum.
hold on. Before you go there, we all measure 9.81 meters per second squared in the vacuums that we achieve. Now, if you wanted to get it measured out to 9.8 and then get maybe 10 to 12 more decimals places, then you might start seeing some differences in a non-perfect vacuum. But since we have a vacuum in the 10 point, or 10,
Negative 5.
negative,
Or-
let's see, 10 to the
You're not
minus
understanding
3,
me. I'm saying you
10 to
would
the
see
minus 3, 10 to the minus
differences
4.
now.
Hold on, 10 to the minus
If the
4.
vacuum chamber was large enough, you would see differences now with that vacuum.
No, no difference in the 9.81. The 9.81 always would be fixed.
You
Would
don't
not
know
see a
that
difference.
because we've
No,
never
we do not.
tested it.
We
You
have
do
tested
know
it.
that.
We
All
have
that
tested
to
that.
see the difference of speed.
We have tested that. Do not listen to me. If we did want to get a acceleration out to 10 more decimal places, then we might have a problem with only using a near perfect vacuum. But because we're only using 3 decimal places or 2 decimal places, we have no problem reaching that uniformly and consistently with every single object we drop.
Oh,
in
yeah,
that
some
knowledge like
yeah,
Xanax.
that percentage.
Same
Do
thing.
you know
That would
how
be the same
how
thing.
statistics
Like-
works? Like, what do you think the statistic significance?
What do you
is?
think the
10 to the negative?
statistics?
10 to the
I'm-
negative 6.
What I'm
versus 10
arguing
to the-
against is that you guys claim it's a constant. If it's only constant
hold on,
until
hold
3
on.
decimal places, and that's what you guys don't.
Statistics.
What do you think
bring
the
up, then it's not
statistical
constant, bro.
significance between 10 to the negative 6 and 10 to the negative 11 is? When
It
our
doesn't
number is
matter.
nowhere near
Exactly.
that level of accuracy, and we're going at 9.8.
No, he's saying it is a
Bro,
constant percentage, but the
constant,
small
keep saying.
atmosphere makes it not.
No, but
But
that's
if you
the
could
problem.
look close
You
enough,
don't know
that
how
small atmosphere
you
would
don't know
show
how
up.
Why don't you
statistics
tell
work.
him a story?
Don, that's the thing though. They've
I
never
wanna hear a
measured it
sto- I wanna hear
in
a story.
a perfect vacuum to know that it is a constant. They're presupposing that it's a constant.
It
No,
is
we're
a
not.
constant.
It's
this
not a
really the
fucking
right
presupposition.
Okay, I can back up what percentage saying. He's saying you've never witnessed the pure constant. You're admitting to
Yeah, it's
only
an
thing that you've ever
average.
been able to
That-
get
that's
is
not-
the
again,
constant.
again,
I get it.
Times
When
that it's an
he's
average.
saying some of the most stupidest things I've ever heard.
Yeah, it really is. Rocket scientist is absolutely correct.
Constant, and I'm saying
It's
yes, it is
irrelevant, but I hear what he's
Dom, I
saying.
just want you to point out you're agreeing with an idiot right now.
I agree that I hear him.
You're agreeing
That's
with an
all.
idiot.
Zanik, can you hold on because we can't. Zanik is making this noise and it's really loud. Zanik, you keep on clicking, slapping something. I don't know what you're doing. Just
Yeah.
I'm not making
stop.
noise. I'm done. I'm
Yeah, no, you are, Botanic. You
Zanik,
are.
stop
You're
doing
always
that.
I saw
It's
the
one thing to hear percentage, and it's another thing to
Just
say
mute
that
him.
his challenge is going to hold up to anything.
John, are you agreeing that you can hear?
Yo, don't
Well, I hear
You wanna
7
make that
people
point
talking
again?
at
You
once,
can
Curve, so I want to join in the party.
Don, don't fall back on what you say just because they chastise you, man.
All right, but can you hear?
No, I'm not. I hear what you're saying,
Can you
percentage.
agree?
You want to chat. You don't have enough to break what
No.
they're saying, but you still want to challenge it.
Well, I'm definitely
Doesn't
thinking
matter
whenever
what he says.
Globe Earther
Can you
says it's a
just agree
constant,
that
that's
you
bullshit.
hear?
It's agreed upon or an average, okay. But you can't say it's a constant if it's never been measured.
Nobody,
in
hang
I
on,
don't
hang on.
know of
No one is
anybody
saying it's a
that does think that's
constant.
Globe Earthers always say it's a constant.
No,
No,
where the
not
fuck
that.
did you get that from?
Not that. Not the
I thought
acceleration.
G was though.
All Globe Earthers, but there's definitely Globe Earthers that say it's a constant. It's a 9.8 meters per second squared. It's a constant.
Well, you go
I think
enjoy
they're
their
wrong.
company because
Uh,
I
it-
don't. It's not a
But
constant.
G,
Tell him again.
Good.
Tell him
You,
again.
for practical purposes and for simplified purposes, you can use it as a constant. Okay, but in itself, it is not a constant.
because there's
All
a
right, next
relationship and there's
Why does it
everything
become a
is
near
different
perfect
always.
vacuum?
Big G is the gravitational constant. That's referred to as a constant.
That's the
This
constant.
rate
But
of
I think he's referring to the
acceleration varies. It's
9.81
not a constant. I don't know what you're talking
approximation.
about.
When does it become a near perfect vacuum?
What's near?
Did you hear about the fact that it
near
doesn't?
perfect? What's near perfect?
I said near perfect vacuum, not perfect vacuum. Rocket
10
scientist.
to the minus 11
What,
is near.
for
10
what
to the minus-
application are you
hold
talking
on.
about?
10 to the minus
You
11
need
is
to
half
be
a-
really honest.
Atmospheric pressure at 14.7 psi.
10
You're pumping
10
out the
10
air,
to the
right?
minus
You're
7.
You become near human.
10 to the minus 7 is
I
the
think
distinction.
he's
That's the
saying
demarcation.
10 to the minus 7 through 10 to the minus 11, their maximum is near perfect vacuum. That's where we use it.
Is that
That's
when-
where that's where we use it in semiconductor manufacture because it is so perfect that we can be assured that we'll have very little.
Okay, so if it's 10 to the minus 6 or 9 to the minus 7, that's not a near perfect vacuum?
Might be near enough for certain applications.
Well, when is it that the feathers and the bowling?
handle
Wait,
that there aren't
hold
that
on a
many
second.
absolutes, can you?
Please. When does the bowling ball and the feather drop at the same time? At
Hold
what
on.
point in the vacuum?
How
What
accurate
does
is
it
your
have to
measurement?
Moon.
Hold on.
What is
It doesn't.
What does
That's not at the exact same time. Their vacuum chamber
10
just
10
isn't
to
large
the
enough
what?
to see the difference.
So yeah, because this doesn't happen in every vacuum, right? You need this special NASA vacuum.
You see it happen on the moon?
No.
Well, can you do this feather trick?
The only time they would fall at exactly the same time is in a perfect vacuum.
Yeah, but
You know,
when?
you can buy a vacuum
at what
machine from
point?
Amazon and do the same experiment. Do a similar experiment.
What basis do you have for this claim, Percentard?
What do you mean, what basis? That's the claim the Globe Earthers make, bro.
No.
A lot of
That
Yeah,
it's
only in
not
a
affected
perfect
by the
vacuum.
pressure, the air resistance, or the drag. So the only time it would ever be at the exact same rate would be in a perfect vacuum, not a near perfect vacuum.
Oh, let's talk about the significance of the effect. That if we're going to get into, what are we into now? Picoseconds? Femtoseconds?
I'm
In
curious,
engineering,
what
we
do you
call that fuck all.
But you still call it a is it inconsistent or not? What's the deal?
Perfectly consistent. So Don, stop agreeing with an idiot percent, okay?
I'm asking you the question.
Don's stupidity is a constant. That you can
That
you
is
can bank
true.
on.
That is an
So,
absolute.
do you want to
universal
answer the
law.
question or not?
I've already answered.
Which
the
stupid
questions.
question are you referring to?
Curved. When you were talking about Big G, could you go over that one more time for me, sir?
Big G is called the constant, the gravitational constant. This rate of
But it's
acceleration
not
is not Big
con-
G.
Okay,
Can
but
we
Big
start
G
referring
is.
to Curve
Hold
as
on,
Big
man. I'm
G?
talking to Curved Rocket. So Curve, So that thing that is a constant, what is that?
You've been arguing this whole gravity thing this entire time, and you don't understand what the hell Big G is.
Well,
First off,
you
we're
guys
talking
are saying
Are
that
you
it's not
fucking kidding
constant,
me,
but it's
Don?
constant. I mean,
No,
I'm just trying to
things, you know
clarify.
what? Don,
Right.
You know,
So,
wait, Don. You know, Big G is different from the rate of objects falling on Earth, right? Those are two different
well,
things.
I think then percentage is probably referring when he says constant. He's probably referring to the one that's a
percentage is
constant.
He's
wrong.
Percentage is
you're
very
possibly
retarded
wrong.
and has never taken a statistics
Like
class.
I said, Don, the constant is your stupidity, Don. Don't assume
so could
anything,
you
Don.
elaborate
Matter of
more?
fact, quit talking,
Hey,
Don.
hey, guys, to be sincere, I got my 11-year-old kid with me
Listen.
right here, and you guys just keep saying dumb.
Less
Why don't you
talking,
teach
more
him something?
listening, Don.
Hey,
Yeah, so I'd like to listen.
Less talking, Don.
The
You sound like real
gravitational
gentlemen, let me tell you.
objects of falling is 9.8 meters per second. Now, the vacuum chamber.
Around. Say around.
Hold on.
Around 9.8 meters per second squared.
Yeah,
Shut
whatever.
up.
Whatever. The vacuum chamber is at a vacuum of about 10 to the negative 6.
In your perfect vacuum, it's not.
No, hold on. 10 to what is it? 10 to the negative 7. Now, if you understood what standard deviation was, and if you understood what variance was, or anything else that would give you brain power to actually understand these very complex things, you would understand the statistical significance of 10 to the negative 7 and 10 to the negative 11 is absolutely fucking nothing, because our
Incorrect.
number is nowhere near that.
Listen, bro, you're assuming.
You don't know
You've
what
never- hold
standard
up, hold up.
deviation is. You don't know what variance. You've never done a science experiment in your life. You just talk out of your ass. You're the most.
No, apparently
you're so fucking retarded.
because
the fact that anyone wastes time
Yeah.
talking to you.
Bro, you've never measured it
on me.
in perfect vacuum, so you're assuming the
Why
scale.
does that
assuming
matter?
It's equally proportionate, or you don't know if it's a bell curve. You don't know what the hell it is.
Even
Sir,
with
assume
5 standard deviations, let's say we're wrong by 5 standard deviations from 10 to the negative 7 to 10 to the negative 11. That's literally nothing. We could be wrong for 10 standard deviations.
Contesting the effect. I'm contesting how they claim
is
that it's
inappropriate here.
No, it's
Right?
the variance too. It's a few
Yeah,
it's a few topics of statistics. Anyway,
contesting how some globe earthers claim it's a constant. That's a constant speed, 9.8 meters per second squared in a vacuum.
multiple people just told you it's an average. The
What are you talking
gravitational
about, bro?
Big G, the gravitational constant, that's the constant, but the rate of things falling on Earth's gravity is
Do you know what?
different.
Twit's right. You know, Twit's right. You never listen, do you? You just keep talking when people talk.
Keep stroking yourself.
To be fair,
Just
Hipsy
shut
is
your
explaining
stupid,
terribly.
invalid mouth for 5 seconds and let someone else fucking finish a sentence
let me
without
finish
your
my point.
fucking
I mean, does your wife,
stupid,
does your wife
deranged,
know you look at
fucking
pictures of all these
inbred,
girls on
fucking
here, buddy?
mongoose knuckle dragging,
Let
little
me know when your
pretender
wife-
clown ass
when are you
talking.
gonna tell
Shut
your
up.
wife? You look at all these girls.
Shush.
By the
You're
way,
just all these
no one has
ladies here
answered
from me.
where the demarcation is between like atmosphere and near perfect vacuum.
Depends on the application.
And
Why?
what does that have to do with the price of corn?
Why does it depend on the application?
Because
That's
precision
racist.
and how much you need of it.
So
Deal with
near
it.
perfect vacuum is whatever you want it to be, basically.
It's whatever you need it to be for what you're doing.
That's convenient,
It's
isn't it?
going to be a small number.
It's an open closed system when you want it to be. You know, the horizon's an elusive.
Rami,
It's there, but it's
don't,
not
don't,
there.
don't.
You know, it's a physical, non-physical.
The near perfect
Yeah.
vacuum they have
And
to build
attractive,
your
non-attractive.
CPU processor. Yeah, I guess they don't know what they're talking about, right? You guys
Oh,
figured it
okay.
out. When are you gonna get
It's
your
just
Nobel
there
Prize?
and it's not there, and it's just there and it's not there again, as usual.
We very rarely deal with absolutes when trying to.
You
do stuff in the
don't deal
real
with
world.
non-absolutes. Give me
Deal
one
with
absolute.
it.
You can't even answer a straight question. Never mind absolutes.
People
I
are
just
trying
said
to
we're
answer.
not dealing with absolutes when we're measuring stuff in the real world. You don't
Yeah.
get the absolutes. Sorry.
Fuckwits
Okay,
keep
cool.
talking over the answers.
I do apologize, Curve. You are
Just
right.
like you don't get absolutely zero pressure, you don't get absolutely one atmosphere either.
And you absolutely
Just
kills
don't get
99% bacteria. 99.9% bacteria kills, but it doesn't kill that 0.01%, does it? So, what the fuck can we do?
Anyways, I got my concessions. That number one, it's not a
You
constant
got
vacuum,
no
and that
concession
they have no
whatsoever.
actual definition.
So
No, that-
stop with your stupid victory lap,
That wasn't
okay,
your time to
percent?
talk.
You got nothing.
You know, that wasn't your time to talk, though, was it? Really, Rocket. You know, let the man finish. Let the man finish.
He's taking a victory lap for no fucking thing.
He's dominated you.
I'm gonna just let him do that.
As soon as you interrupt him,
he doesn't even. Okay, let me see how much domination he has.
Have you ever heard of globe Arthur? One second. Have you ever heard of globe
How do you calculate the value of G? Of little G? How do you calculate it?
We're glad you guessed. You got close to it. We're glad. You've assumed what the whole
How do you
thing
calculate
is.
it?
It's cool.
How
We're
did you
glad we all
calculate
agree.
the zero fairies? How'd you calculate fairies? How'd you calculate unicorns? How'd you calculate something we don't believe in?
Rami, stop being a blowhard, okay, for a moment. I'm asking a question. How do you calculate small G?
Don't assume shit just because you can't understand the point that I'm making.
I asked you a straight question. You don't answer that.
Rocky, he doesn't know. He doesn't know.
It's not nice when people don't answer you straight questions, is it, Rocket? It's not nice.
Shut up. What is the answer to that question? 5 people know the answer in their head right now.
Exactly. It's horrible. It's horrible, isn't it? It's horrible.
By the radius of the Earth squared. Shut the fuck up.
Bro.
He just parrots. Wait, what'd you say? What? What?
How much? Say it again. Come on.
What the fuck did he say?
Oh, you guys couldn't catch it? Slow brains.
Yeah.
Well, it took him that amount of time to Google it.
We got Google too, motherfuckers.
I swear on my lord that I did not Google a thing.
I don't give a fuck about what you swear on, okay? Because your credibility means shit to me and everybody else.
I asked you a simple honest question to
I believe him too, but y'all still disrespectful that Google's that everybody's favorite.
I'm trying to dodge Rocky's question. Answer his question.
Put some respect on his name.
He fucking answered.
Listen, percentages, don't answer his question till he
have
answers
one at
whether
a time,
his little
please?
density tower had containment. Yeah? Till he answers my question. Don't answer Rocket's question.
You answer
deal with
stupid
answering questions. So why
okay?
should you?
Bro,
What?
there's a reason you're muted all the time, dude. Stop interrupting.
Bitch, listen, I will take your pants down,
Rocket,
yeah, and I would drive my bulbous penis in between you.
Okay,
You understand?
turn
You understand? I will pin you down, yeah. I'll take your manhood, bro.
I answered the question. If he wants to play it back in the recording, he can.
So then what's the variables that would cause the variations in G, small g?
The ones that they assumed?
Sure, dude.
They assumed the mass of the Earth. They assumed the radius of the Earth. So from that, they got big
Those
G.
aren't assumptions.
Which they probably,
That's not how
they're
big G.
Those are measured.
Aristotle assumed the
No,
radius
they're
of the
measured.
Earth.
That's a
because
measured value.
The sun was far and large,
Measured value.
and thus had parallel rays. All
They're not
assumptions. All
assumptions. They're
non-separate.
measurements. We measured those values.
All bullshit. Fallacious. The whole globe religion is fallacious.
They're not assumptions. They're measurements. We measured those values.
But you can't tell me just in that equation why there's a variation in G.
Did he really measure, or did he measure the distance of the sun and the size of the sun?
Yeah, but if you know trigonometry, you don't need a fucking tape measure that's 90 million
Trigonometry
miles
assumes that
long.
it's a solid
Like, just because you're stuck at that low level of thinking doesn't mean the rest of the world is.
Yo, even if you're doing trigonometry, you're assuming it's a solid object of mass, right? So you're still
No,
making.
you don't need to assume anything to know
No,
the
you're not.
distance
You're not
of
assuming it's a solid
trigonometry.
object.
You know what trigonometry is? What? You are incredibly ignorant on so many topics. Percentages is hilarious.
I'm way more qualified than you in any.
You don't know anything about anything, dude.
No,
You
you're
just
not.
talk- you're the
No, you're
least
not.
qualified
You're
person in
arrogant
this
if you
group.
try to say
You're literally the least qualified person.
Dominated
in
you
this
on
group.
that one. You assumed the curve. You assumed what kind of curve it was, the scaling of the stats. So you have no clue what you're talking
Why
about, bro.
do you need to know what the sun is
you
made
assume
out of?
so
To do
much?
trigonometry to find
Why
its
do you
distance. What are you
assume so much?
talking about? Again, you have no idea what you're talking about, dude. You just repeat
Why
QE.
do you agree with
You
saying
don't have
I
a
don't know?
single original thought. You're just
you
a
don't know?
you're a
Why do you-
recorder of everything in 24/7. You're just a
Why
recorder.
do you assume so much? Why don't you just say you don't know when you don't know?
Anything. Just do
Be
some simple
intellectually
math,
honest.
dude. It's pretty simple math. You don't need to assume anything.
You are assuming.
Measure
You're
some
assuming what
angles,
it is.
and you get
You
the,
know,
you
we
get a
can
distance.
measure
It's
that
really
pretty
not that
easily.
hard.
You can measure it pretty easily.
You measure the the
What's
downward
harder to
acceleration
measure,
in
though?
perfect
The
Percent,
distance,
if you're
you
going to
know,
try
the
to
distance
argue
of the
somebody's
sun,
position, at least understand what that position is.
the distance of the sun, the shape of the earth, all are measurable. Not a problem.
Percentage, you got to take it easy on the
Can I
Globers, man. They've never
clarify
fought for
this?
they've never fought for themselves one day in their life. Do you know what I mean?
Can I just
They've never fought
clarify
for
this?
themselves ever.
Bro,
You gotta take it easy on them.
When you turn down Brahmi, it just becomes so much more peaceful. I'm just
You gotta take it easy on them, bro. You gotta take it easy on these guys, man. They've never fought for a day in their life.
I just want to clarify. I'm just going to clarify. I just want to clarify. Is big G harder to calculate than little g?
Oh, great. Stiggy's going to clarify.
Wait, is it true? Is that true? Is big G harder to calculate than little g?
No.
Yes, it is, because that's what was measured in the Cavendish experiment, and that's what has been always refined over the years to get a better value and better estimate of that constant.
Yeah, because I've seen there's been so many
calculating.
It's
not harder. They have the same variables.
There's been so many
It's just as easy to
setups trying
calculate.
to
So,
find
but
big
if we
G,
understand it's a 99%,
and it's really
99.99, what's your
difficult.
point percentage? Your point is literally we don't know 100% of it, but we know 99.999.
You don't know how that last percent
That
scales.
you are
bro.
like, what
On
is
the
your
last point,
position? Your position is so
scale.
stupid. This is
You're
ridiculous.
assuming no, you're dumb. You're assuming it scales equally like all other ones. You're assuming that's a positive, a direct linear correlation. You don't know that. It could be exponential. You have no fucking clue.
It works. What do you mean? How do you think your CPU processor works? How do you think anything that you use works?
Dude, we're not talking about whether or not it works. Of course, that's the effect that we're seeing. But there's globe earthers that claim.
Oh,
this is
wow.
how
Okay, well, I mean, you just admitted it works. I mean, you got that out of him. There you go.
It would be in a perfect vacuum. They claim that. They assume that. They don't know that. Everything we've dealt with
all works, right? It just all works so perfectly, right? These conspiracy people, the people that made the globe Earth religion, they went like overboard to make sure we're all right?
Can I ask percentage one thing without being interrupted for a second? Hello, you guys have been babbling on top of each other. Can I ask percentage one question without being interrupted, just for like 10 seconds? Percentage, if we could measure something dropping in a vacuum at 10 to the minus 7, and then measure it again at 10 to the minus 11, and then we can get a correlation there, would we not be able to predict what would happen at 10 to the minus 17 or higher? Wouldn't that be fair to say we could predict that?
No.
Okay, that just shows your intelligence level.
No, it shows your intelligence. You have two data
It
points.
shows this guy
Whether it's straight or
his entire argument. If you break down his entire argument, it's so silly. So you understand this topic by 99.99999%, but you're missing that 0.0001% of it. Therefore, everything you know is somehow wrong.
Yeah, let me finish my thought percentage. Let me finish my thought. So hold on. You're right. So, hold on. Can I finish my thought, please? Can I finish my thought?
Go ahead.
So in aerodynamics, and that's something I studied when I was in school many years ago. But what we found is we can figure out what the drag characteristics of any object would be in the wind tunnel, and regardless of the level of vacuum, we can plug those numbers in, whether it be pure vacuum or a few particles, or 10 to the minus 7th, or 10 to the minus 2, or 14.7 psi. We can do all that. Hold on. We can do that all day long till Tuesday and never be wrong and never be off our mark for designing airplanes that fly at breakneck speeds all day long, and there's millions of hours of flying that goes on a day-to-day basis. So why do you think we can't determine the drag characteristics of an object in a vacuum with all the knowledge that we do possess about how things move through mediums based on the density of that medium? Why do you think we have no
perfect vacuum?
Yeah, of course. We know what happens in a perfect vacuum. That value becomes zero.
How do you know that though if you've never measured it?
We don't need to observe it. That's what calculations are for. We don't need. It's like using trigonometry to determine how high.
You don't know.
Hold on. We don't need to measure a tree by using a tape measure if we know the angles. We know by calculations what those angles and distances will represent. So we don't need to go there with a tape measure. Yeah, we'll never in our lives ever go to the top of that tree, but we will know within accuracy of those devices about.
No, bro, that's a false analogy because what you're saying.
No, same thing. It's all about calculations.
You've never seen it. You've never
seen. We don't need to. We know how the particles act on. We know how the particles act on objects moving through the medium. There's distinct calculations based on temperature, the density, everything.
Let's take your tree analogy, okay? So let's say you measure the tree at 10 years old, okay? And then you measure it again at 13 years old. And let's say the tree is fully grown at 17 years old, but you've never once seen it for some reason. You're in an environment that you don't have fully grown trees for whatever reason, right? So you measure at 10 and 13 years old, and there's you notice how much it grows. Now you're assuming at 17 years old that it's going to grow at the same rate. You don't know that. Maybe it has a growth spurt at the end. Maybe something changes. You don't know the variables involved. You've never seen a fully grown tree. That's exactly the same.
That's a good example.
Never seen it.
Hold on. I get the point. Stop. I get the point. But it's not analogous. That is completely wrong analogous. We do know the variable. There's no other variables involved in this measurement. None. Your tree has all sorts of variables. So if you're doing science on that, you'd have these independent variables along the way that you have to, and your control variables along the way that you wouldn't be able to control for those remaining 4 years, from 13 to 17. Hold on.
Is a perfect vacuum purely hypothetical?
A perfect vacuum is hypothetical.
Yes or no?
But the value for the molecules or atoms that are particles that are in that chamber are very real. They're part of the calculations that determine what forces will impart.
Is a perfect vacuum hypothetical? Yes or no?
A perfect vacuum is hypothetical. Yes.
Okay, so because it's hypothetical, you can't know what happens in it because it's hypothetical.
No, that's not true. That's not true.
By definition, you can guess.
That's not true at all.
You don't know. You can
That's
infer.
not
You
true
don't
at all.
know.
No. If we can hold on. No, I'll give you an example. I'll give you an example. If we can only measure an I'll give you an example. If we can only measure an angle to a value of 5 decimal places and a degree, okay, we measure it in degrees, but we only have 5 decimal places. It wouldn't stand to reason that we would not know what that angle or what that distance would be if we could take it out to 10 or 20 decimal places or infinite decimal places. It's all just math. It's very easy. You're talking about a completely non-analogous comparison. I like your vigor and your enthusiasm, but you're wrong. And you're being retarded.
I made it analogous. You've never seen.
You can do whatever you want, but you're just wrong. I'm sorry. You're wrong.
Analogy. You've never.
You're wrong because we have the calculations based on the particles in that chamber. How much forces? We know the forces that they will produce on the object. We know this. This is basic science as engineering.
You yourself.
We know this.
Zanik,
No need to explain.
Zanik, you've made the point. Let him respond.
You yourself admitted that a perfect vacuum is hypothetical. It's never been observed. It's never been seen. We can't make one. There is no perfect vacuums. So everything you say about it is hypothetical. You can't say something is actually true about something that's hypothetical. That's like literally fallacious. Do you understand that?
Your argument doesn't make any sense, percent. It's like
you don't make any sense at all.
A tree on Earth, and we measured it, and we used trigonometry to find the height, and we went back and we double checked it by measuring it out with a tape measure. And then we went, okay, well, that tree was, say, 300 feet tall. It's the tallest tree on Earth. There's not a single tree that's taller than that. What you're saying is, oh, well, what if I thought about a 305-foot tree? Well, trigonometry might just stop working for the 305-foot tree because we've never actually measured one. And that's insane.
And that's a great analogy, by the way. That's percent. That's a better analogy.
It would grow to 300 feet in the exact same proportions that it would grow from 13 to 17 feet.
It doesn't matter. All we know is
that we can measure a 300-foot tree from a distance using trigonometry. And you're saying a 305-foot tree, because we've never seen a 305-foot tree, trigonometry just doesn't work anymore.
I'm switching the numbers. Keep it consistent. They're saying there's no
300 and 305.
Okay, they're saying that there is no 305-foot tree. So to assume that the rate of growth from 300 to 305...
Not rate of growth, that we can measure it using trigonometry.
You can't measure it if you've never seen it. You can only...
Exactly. So what you're saying is trigonometry stops working if we try to use it to measure something that is bigger.
Like measuring and calculating?
That's crazy.
Do you know the difference between measuring and calculating?
But, oh my God. It's there. Yes, there's a calculation involved with using if we know an angle to
from 13 to 17 feet and applying that to the 300 to 305 feet or what have you. You can't say that they're going to grow at the same rate. That's assuming things. You don't know.
We're measuring particle impact, like quantizable particle impacts on an object moving at a speed through a certain air density. It's quantizable. We can break it down to the individual particles and quantify that. And you're saying if we remove that one more particle, suddenly all of physics stops working because we had one less particle collision.
If you can't stick with an analogy just because it's like too tough for you,
that's the pressure. That is pressure. That's not a different analogy. I'm literally talking about the pressure situation.
Measure hypothetical.
Quantize the particle. We can calculate out every individual particle collision in a certain pressure situation between an object and the surrounding air. And you're saying as the pressure gets lower and lower and lower, we can still quantify the number of particle collisions. You're saying at some point, the particle collisions will go from 1 to 0. And when it goes from 1 particle collision to 0 particle collisions, all of physics stops working. But when it goes from 2 particle collisions to 1 particle collision, everything keeps working exactly the same.
I didn't say that at all. I just said
that is what you're saying.
Bro, I'm saying you cannot measure a hypothetical and you cannot know a hypothetical. You can't claim it as truth when it's still a hypothetical by your own admission. So if you guys have problems with that, then take it up with like simple logic, because that's what it is.
No, what you're saying
That's
is
not
if it's beyond a situation that we have physically measured, that all of the rules and the situations, the physics behind it might suddenly change, even though we've quantified it in every other increment.
They might be different. It might grow at a different rate. The true might grow at a different rate. You don't know. That's the
We're
point.
not talking about the rate. We're talking about the actual value.
No, for sure.
I would say none of this was talking about the rate of growth of a tree. Like you.
Wow, man.
You clearly don't grasp the analogy that I made.
You can't hang with the actual argument, bro.
I made an analogy about the height of a tree, and you're talking about the rate of growth, which has nothing to do with my analogy.
And you piggybacked off of it and actually made it more complicating by introducing new figures.
I made it less complicated by not talking about anything other than the height of the tree.
You had to backtrack from that analogy because you couldn't even understand it properly. And then you came up with
I used the analogy and then I went back to the original station so I could apply the analogy to the original situation. Why is this complicated for you?
It's not complicated because you guys don't fucking listen either. It's a two-way street. He's trying to get his point across. You're trying to get your point across.
Jump in. He's wasting.
No, I'm just trying to explain. I see the problem on both
You're trying to save
sides.
someone who's brain dead right now. You're seriously.
I'm the voice of the truth. I am the people.
You're nothing. You've been hit too many times in the head.
Gone quiet.
We're exhausted. Just
Yes. Time for the roundup.
Hippity is still muted.
I didn't mute him. I said I was going to mute him. I didn't mute him. He's been barking. Do you know, it's really funny when the ballers bark up the wrong tree and they say chemo. It's like it wasn't even me.
Captain Bullshit, I believe, because he just lolled, maybe.
Yeah, so that's why I was like laughing at him a little bit, because obviously.
No, the other Taylor made a great point. He gave him a perfect analogy, and he's just in defiance. And he's stuck on the wrong track. We're trying to bring him back, but he doesn't want any part of it.
Man, you don't have
Oh, it's not a roundup. I thought we were gonna analyze.
You know, it's about time I got some chemo in it.
Carry on.
We need some specificity chemo.
Yeah, carry on. I thought it was quiet. That was all. Carry on.
Brummy, get your own words.
I don't say the word. Can you pronounce it for me?
Hanging on 24/7 and bringing their crap lines over here.
No, well, we need specificity. Do you not agree?
Can't even say the word, can you?
He's been trying to say it all
can't even say
Why the fuck do I say it? Someone help me!
Because you've been hitting my head too
I
many
need a
times.
white knight.
Go on, do it with me. Do it with me, Brummy.
Spess.
If
Spess.
it e.
Specific.
There's a lot in there.
Specificity.
Specificity.
Brummy never finished middle school. Not his fault.
Specificity.
It e.
Specificity.
I've made it harder.
I mean, you are definitely entertaining. I'll give you that. You're definitely entertaining.
I'm genuinely trying to say the word.
It was hilarious. It was just like watching a train wreck in slow motion.
Specificity.
No,
No royal fail.
You just stumbled on the step there, didn't you?
You guys are giving him a rough time.
No, there's one more. Spec if is it e.
Spec if is itty.
Yeah.
Spec if it
There
is.
you go.
You're not going to be able to do it.
Graduated to middle school, Brummy.
You're not gonna- Brummy, I posted your scores. I posted your score in chat.
You're at a middle school reading level now, Brummy. Good job.
Thank you. I do appreciate the help, Jem. Honestly, I needed a white knight. You can always rely on Jem to save the day. Let's say that much.
Glad to be of service.
No worries, mate. Everyone else just left me out to die. Struggling on a single word.
No,
Well, you know, I think I enjoy the way I say it a bit more. You know what I mean? Gives it a bit more fucking spinazz.
Probably say it in normal talking speed now.
So percentage, are you really that confident that you can't complete that graph that I posted?
Are you really that confident that's a directly, perfectly linear relationship?
Yes.
Really?
Yes.
Well, the force of drag is force equals coefficient of drag times pressure times volume squared times area divided by 2. Yeah. So, ignoring all the other factors, the relationship between pressure and drag is linear.
Let's ignore all the other factors.
Well, we weren't talking about the other factors, were we? We were only talking about the pressure.
We could use a coefficient of 2.2 and call it a day.
Those other factors are what we call control variables.
Exactly.
And we only need half that graph to do what we're doing anyway, so what do we care? These are areas we've actually visited.
Engineers piss off mathematicians by making simplifications.
Man, put a cigarette in front of a fan and call it a wind tunnel and make it a day.
I mean, the rate of it falling is the same at 10 to the negative 3. It's the same at 10 to the negative 4, 10 to the negative 5, negative 6. I don't think, like, I don't know what you think 3 more decimal places is going to do.
Or 10 more decimal places.
You guys are being right now. You guys are trying to
or 15 more decimal places. Or 20 more decimal places.
Take away those 3 more decimal places. That's the only place where percent's arguments actually lie.
Oh, I see.
Close to 0.
Hey, what's the drag? What's the equation? The drag equation. Anyone of y'all?
There it is.
Sonic, this clicking is I can't.
Oh,
how?
look at that. There's a square in there, huh? So it's not.
Guess what it's applied to? The velocity.
Yeah, the velocity of the object that's falling, right?
It's the velocity. It's not
Now, what are we
anything to do with the pressure. It's the velocity.
Falling in a vacuum.
No, that doesn't be falling. That applies to an airplane flying horizontally as well.
Or
So we're talking
Or a
about
satellite.
falling or moving or
soccer
whatever.
ball.
The point is that it's squared, so it's not directly
What
linear.
is that?
relationship. So
What is that?
Oh,
V?
like
what
I
is that
said, we were
variable?
controlling the other variables and only concerned with the relationship between force and pressure.
Talking about the speed of things falling in the vacuum, man. If you want to take away the context of it, just to try to stroke the ego.
Just to continue with using
pressure, not drag
we'll
versus
directly
velocity.
address the square there. When we let something go, its velocity is very small. And as you know, in a squared function, below 1, things get smaller even faster too. So at low speeds, such as when you first release an object, velocity measures even less.
Exactly. So it would show you that it's not a direct linear relationship. It's not a straight line.
With pressure, it is though.
You're not understanding what's being said.
Pressure, buddy. We're looking at an object falling in a vacuum. That's what the scenario was.
But you were arguing about pressure.
Drag
Pressure
versus
in a vacuum. We're not
velocity, it would
talking
look
about
different. But the
We're
plot is
talking about
drag
how it
and pressure.
scales.
Yes, how
How it
drag
scales with
scales
pressure.
with pressure.
How the object falling scales with pressure.
With
Yes. So
pressure.
it's talking about an object
Linear.
falling.
It's
So
linear.
again, the velocity of the object matters.
Yeah, we never said that it didn't.
Well, you guys just said right now.
But
it
we were
doesn't
talking
matter.
about the way it scales with
All the
pressure.
I distinctly heard someone say all the other variables are constant. So speed of the
No,
object
hold-
falling.
I
hold
didn't
the
say
other
constant,
variables
we said
constant.
control.
Out here.
He
In a
said
situation
controlled.
where you're testing drag against pressure, you control the other variables.
We're not doing that though. We're talking about the
Well,
speed.
why
of
aren't
the
you doing
linear-
that? You should be.
Literally drag
Control.
versus pressure. If you look on one side, it says drag, and on the other side, it says pressure. This is a plot of drag against pressure.
No,
It is
pressure.
linear.
This is the other Taylor. Like, what's wrong with you, buddy?
In the
You're not
linear
understanding the
plot,
scenario
the
of
linear
this-
plot that you are complaining
Bro,
about,
do you
the
not
plot
understand the scenario,
axes
like,
are
how this-
drag and pressure. I
Do you
can
not
read it. It's
understand
got
what
2
we're talking
words
about,
written
bro?
on it: drag and pressure. There are no other words on that plot.
Again, I didn't make that, bro. What are you talking about? You're talking
you're
taking someone else's thing and
The
taking it as gospel.
relationship between drag and pressure is linear when velocity is squared, but this is not a plot of velocity. This is a plot of drag and pressure.
No, what this is an argument about how things would fall in a true vacuum and a perfect vacuum versus a non-perfect vacuum. Okay, and whether or not we can just assume the speed that it's falling is a
between
direct
drag
linear
and pressure is
relationship,
not linear,
or
which is
if we can't
incorrect.
actually say that because we don't know. So if you want to piggyback on half of the conversation and talk out of your ass, that's fine. But that's not what we're talking about, bro.
Are you implying if we got a vacuum with 5 more decimal places of accuracy, this would somehow debunk gravity?
No, that's not what I'm implying at all. Gravity, there's no
What are
essence of gravity. What is gravity? We're talking the cause. We're talking about the effect right now.
Do you know algebra? Because this is basic algebra here. Do you see what these symbols mean? It looks like a bunch of letters, but they mean something. You got the drag, and 1/2, the rest of this pressure, area, the drag coefficient, and then velocity squared.
How we can know.
So if we don't, hold on. If we only change the pressure, that relationship between drag and that velocity will be linear.
You said we're only changing the pressure, bro.
You did.
We're talking about things falling in the vacuum.
We're only going to change the. We're only going to do one thing. We're going to do one thing. We're only changing one. We're only changing one thing.
We're going to yes or no?
We'll change the vacuum.
You can't ad hoc. You can't ad hoc an argument by just say, "Oh, we're leaving everything constant," when the whole conversation.
That's what the whole fucking discussion was about.
You didn't say constant.
This is
a straw man.
Yeah, it's not constant. We're saying we're keeping everything the same except we're changing the vacuum.
The only way you can win is straw manning it to make it
I'm
say
not
like.
straw manning. I'm just you agree. We're going to keep this whole formula the same. All we're going to do is change. All we're going to do is change the pressure. P is the pressure.
When did I say the only thing we're going to change is the pressure? When did I say that?
I'm saying that.
Exactly.
We're all saying
so
that.
You're arguing against yourself. Good job. You're arguing against yourself and you're still losing.
You think something else is going to change? What else is going to change?
Yeah.
You're still losing.
Hold on.
Be real
What
here
else is
for a
going to
minute.
change? Wait, hold on a second. Let me get this one.
Yeah,
what do you
go
think
ahead.
is going to change now? Can anything else change in this equation?
You will change.
No. We have 1/2. That's not going to change. We have the area. That's not going to change. The coefficient of drag. That's not going to change. And the velocity squared. That's not going to change. So what is your issue?
Objects that's falling not change if there's more pressure.
Oh my God. Seriously?
Exactly.
No. So are you being for real? Do you know what this equation says?
If
It
there's
says
more pressure,
if you change the pressure at any given velocity for that given area and coefficient of drag times 1/2, the force of drag will be some value. That's all this equation is saying. That's all I've been telling you. You can't even understand what the equation says.
No, I'm saying if you looked at it again,
percentage. We're looking at how what changes when you change the pressure.
Oh,
you were the one going on about how.
Question for Zanuck. If you look at it again after a little bit of time, velocity have changed? Yes or no?
Yes, of course. Exactly. And the drag would be the velocity squared at that velocity times the frontal area times the pressure times 1/2, and that would equal the force. So we know that force due to drag working against that velocity will be a value that this equation determines.
Great.
It's very simple.
If we don't know what the pressure is going to be exactly, how it's going to scale, and that,
oh my God! This is like banging your head against the wall over and over.
You are banging, Zanuck.
And asking somebody for a brick to hit your head with.
With somebody that's never taken a physics class in his life.
I know.
If we had
we're being a little hard on him, but still.
Percentage. If we have your arbitrarily high vacuum chamber that you want, and we drop some objects in it, they're going to reach arbitrarily high velocities. Therefore, they're going to go through every possible velocity in between. So concerning which exact velocity it's at any given moment isn't relevant if we're looking at what forces are acting on it. Over that course of being falling.
That's not what the point is. The point is the velocity changes when you guys were trying to say it's constant.
Oh, fuck, man.
No one said it's
retarded.
constant. Fuck.
Really, no one said all other
that was the best
when
question
you are
so
trying
far.
to establish the relationship between pressure and drag, you control the velocity. That is what we said.
So
Did any
how
of
about
you
this
think
way? How about this?
other variables are constant?
No,
Yes or no?
controlled.
I think we're going about it the wrong way. What is the drag coefficient? Excuse me. What is the force due to drag when the pressure is 0? Can you give me a value based on this equation?
0 would be 0, bro.
Be 0, right? Now, if we change that pressure to 10, just throw some numbers out, 10 to the minus 17th or something. What would that value be then?
You do the math. You named the number.
Well, the math would be you take 1/2 of that value times the area times the coefficient of drag times velocity squared at any speed you're going, any velocity you're going. So you get a very, very small number. You see? So we will get such a small number that it will not be a factor, because all we're changing is the pressure. This equation only talks about the drag factor, and if it's 0, then the drag is 0. It's that simple.
Fantastic.
I'm glad we can all agree when pressure is 0, drag is 0. We're all finally on the same page.
Yeah, but how do we know that if we've never seen pressure being 0?
And now we're not.
Yeah, just immediately step backwards.
How do we know that? Again, like we can only
Because
guess
there would be
that.
nothing for it to drag against.
That's what we think. But
No,
we don't know that.
By your reasoning, we never could know anything about anything.
No, we know the things that we observe.
We
This
can
we've never.
predict
Yeah,
them
but
based
what
on
if I
our
add one more
observations.
decimal place to what we observed? Do we suddenly not know anything anymore? If
Who
we
knows?
measured,
If you observed it.
Let's say we measured the drag at exactly 14.500000000 psi. Well, what happens at 14.50000000001? Well, no one's ever measured that, so anything could happen. That's your argument. It's insane. It's an insane argument.
No, you're strawmanning me. I didn't say anything could happen. I just said that we can't say for an absolute fact that X would happen because we don't know how that last decimal
We
spot
understand the
would
relationship. We
scale.
can make predictions based off of the relationship.
Yeah, we have
Yeah,
a
of
law.
course,
That
you can make
means you
predictions.
can put a
100%. You can make predictions. You can you can infer. Using abductive reasoning, using whatever
Yeah.
models, you can calculate. But you can't measure directly, like Zanuck or like the other Taylor said, and you can't know the hypothetical without measuring it.
You don't need to measure something
you
to
only
understand how
predict it
something's going to
technically.
work.
Yo, I'm not arguing that.
Yes,
I'm
you
correcting
just said
their
that.
faulty logic. What?
You literally
I
just
never
said that.
No, I said we can only like reason it. We can infer it. We can
Yeah,
predict it
and we can
speculate
know
it.
things
you have
based
a
off of
problem with
inferences.
Anyway,
We can know things
can't
based
know
off
it.
of inferences.
You cannot know things off of
Yes, you
inference.
can.
No, by definition, that's incorrect. An inference means it's a guess. You don't know it. You're inferring it because you don't know it.
We can do an experiment to check if we were correct, and then if we were wrong, we'd have to fucking reevaluate our model. But
Yeah, that's fine.
But based off of those equations, everything matches up so that equation applies all the fucking time. It doesn't
It's
change.
fine, but you don't know it.
It doesn't
in
change if you put in a zero.
hypothetical scenario.
It still makes it 0.
You don't know that again.
Percent. You don't like the word infer? Then why don't we use extrapolate?
Yeah, but it's extrapolating to a hypothetical. So again, you still don't know.
What the fuck is extrapolating to hypothetical mean?
Hypothetical is 0 pressure. It's never been observed ever.
So
You're worrying about the effects of a proof we will never see.
I'm just teaching them to be intellectually honest.
No, you're not.
No, just literally putting your head in the sand.
They
like
don't
a
know
clown.
that you
Don't
have
claim
that
things
are
in truth
inferred.
if you don't know. It's really an easy lesson here.
Wait, percentage. I have a question for you. So this vacuum is good enough to make 7 nanometer CPU chips, but not good enough to observe 2 falling objects.
What do you mean not good enough to observe 2 fall? Of course you can observe 2
Is
falling
really the
objects.
hill you want to die on, buddy?
Can you frame a better question, you dumb kid?
The vacuums that make the transistors and computer chips and all that. The vacuum's good enough for all that, but somehow not good enough to watch
What
2
kind of
objects
appeal
falling.
to emotion is this, bro? I just
It's
said
saying
it's
it
a perfect
wraps-
line for looking
wraps
at 2
back
objects
around to
falling.
infinity at 0.
Appeal to emotion. What?
Yeah, that's what it is.
The drag force must wrap around back to infinity at 0. That's what he's saying. It might do that.
Oh, I see. Okay, yeah. I didn't think of it that way. That makes so much more sense.
Percentage here in the real world, we apply those laws that we discover from the observations we can make, and we have never found values of other measurements we want to make that don't follow the laws.
Really?
So yes, really. So you worrying about a
So how
condition
come-
that will never.
Hold on,
You
hold on, hold
worrying about a condition that will never. You said yourself, we cannot have a perfect vacuum. Therefore, we do not need to worry about whether the perfect vacuum follows the law or not. What we can do though is extrapolate or infer from the measurements we can do of what will happen if we were to get down there. But no, we cannot check a condition that we can never create. Is that
actually? I can do one better.
That's what you want to teach us, is it? That we cannot measure things we cannot measure. Gee, you're a genius.
No, it's that you can't claim to know things that you can't actually measure that are hypothetical.
I can do one better. We could create a chamber and measure the pressure.
Whoever was speaking before, thank you for your honesty. Thank you for being intellectually honest.
We can create a chamber, measure the pressure to an accuracy that we can time the collision, the time between collisions of particles and the object that is falling or moving otherwise in that pressure. And in the gap between collisions, we do not see a different behavior. We can quantify that.
Your whole reason to exist, your purpose in life, is to remind us that we can't do the things we can't do. Right.
Yeah, well, actually, that's a good point there when you get down to timing individual particles. Because there is, you could say, perfect vacuum between the particles in the not quite perfect vacuum.
So yes, in these non-perfect vacuums, there will be times where no particles are colliding with your object. So in that instant, that object is in effect in a perfect vacuum.
And you will have
we do
to
not
apply
see any weird behaviors there.
You would have to apply stochastic and statistical processes to calculate things like Poisson counting, because you will not get that linear response anymore.
I mean, yeah, it would be wildly complicated, but I think the point is we don't suddenly see a behavior where an object suddenly stops moving between particle collisions or instantly accelerates to 500 times its previous acceleration between particle collisions. That's just not something that's observed.
No.
Which is why that drag force calculation is a very, very, very good one.
So we'll leave percentage to worry about possible.
It's definitely a good equation. I'm not saying it's not.
We don't actually live in, and we don't need anything about.
I need to thank Dan
and
for his
just carry on.
response
We'll
right now.
just carry on using numbers.
But so are you one of the Glovers carrying on? Or you? I see your Pluto planet or your Jupiter there, or Saturn or Jupiter, whatever that is. You Glovers are stupid.
Yeah, that's why you use Glober technology in every part of your life.
A circus monkey scratching his head and saying, "You Glovers are stupid." Imagine this.
I want to be like a rocket scientist.
Hey, Don, how does it feel to use Glober technology in every aspect of your life?
I know the true flat Earth technology. Fact Earth.
Somebody commenting about my picture, my avatar.
You've been deceived. You just think it's a ball, and that's why communications wrap around the ball because of gravity. Communications can be on a flat Earth. You don't know if it's one tower per person, for every person. You don't know how many towers it is.
You're dumb.
Picture of Jupiter.
Glovers are dumb.
Holy bad troll.
Percentage? Have you worked
really
out how?
Are you gonna write that percentage? You're probably one of the worst flat earthers to debate this topic ever.
He's a troller, dude.
You've been stuck on this one topic for like the last hour. It should take you 2 minutes to understand it.
He's stuck on it because Glovers are dumb. You don't listen to him.
From the mouth of Dawn, right? Okay.
You keep telling him about the constant and then saying there's not a constant. It's so beautiful.
You don't even know what you're talking about.
I had a harsh way of saying that, and I was trying to water it down, but you did it for me, though.
Everyone else is wrong. It's just these guys with no science background and just the middle school knowledge. They get it. Everyone else is wrong. Don't you guys see it?
I have no science background. Okay.
Well, that's obvious. Thank you for confirming that.
Everyone else, all the millions of people that work on these things 24/7, they're wrong. But these guys with the middle school education have figured it out.
You're so weak.
Go figure.
Percentage, man. You figured it out. Everyone else is wrong, dude. You figured it out.
He's agreeing with you, and you don't even hear it.
Yeah, I'm agreeing with you, man. You figured it out.
I don't need your patronizing. Get out.
The millions of people that constantly work on these things, and the billions and billions spent on all this research, they're all wrong. But you figured it out, and you don't even know what big G or little g is. Good job. That's an accomplishment right there.
Is the master of the trivial and the irrelevant.
A flat earther's gut feeling triumphs anything else.
Percentage was completely flummoxed by how 2,000 years ago they may have been able to create a perfectly vertical well. 2,000-year-old technology, couldn't work it out. No idea.
Tell me how they measured a perfectly vertical well. It's what decimal places is perfectly vertical. It should be, perfectly vertical to
The alien technology.
The
aliens came and did it.
We told you what the acceptable error range would be, half a degree.
Well, then it's not perfectly straight now, is it?
Oh, very good one. Excellent.
You got me again. Yeah. So you can't. So can you tell us how you could make a well vertical enough within half a degree?
Policy. I didn't claim that they could. Nice try though. You claimed it.
You did.
So you showed me.
You did say that. You did say that all the wells back then would be wonky because of some reason.
I did not say that, you liar. You're a bold-faced liar.
Well, so do you think the wells would be straight, or do you think they would be off?
Who knows? I wasn't alive at that time, so I don't know if it was perfectly. I don't think they would be perfectly straight.
And there's certainly no wells still around to look at.
Yeah, and you can't think about how well it might be made and think about what you could do, and there's all
that's not my job. He's the one that made the claim.
I'm just curious. Well, there's no burden of proof if you don't have an opinion. If you don't have an opinion, you just accept what he has to say.
Why would I do that?
Well,